Alright, so you're having trouble with 9.3. I want to go over the altitude on hypotenuse um, index card activity that you guys did. And basically what you've got here is you've got a triangle, and on that triangle you've got a right angle in this corner over here. So thus, this is a right triangle, and you've got, this is the hypotenuse over here, since that's the right angle, and the hypotenuse is always opposite the right angle. And then you also have an altitude coming from that right angle drawn to the hypotenuse. That's why these problems are called the altitude on hypotenuse problems. So basically what we've got here is we've got three separate triangles. I've got this little triangle over here, I've got this medium-sized triangle over here, and then I've got the big triangle over here. So there's really three triangles going on. Now, what I did was I just took, so that way you can see them all, we took like this triangle that was on the left, and then like I made that's an exact replica of it, and then this triangle on the right I also made an exact replica of it. And if you notice, like I tried to make it so that way like these both were pinks to help you match them up, these were both yellows, same thing on this one, okay, these were both blues, those were both yellows there, and then the altitude that these two shared, I just highlighted those as orange. So essentially here we know that all three of these triangles are similar to each other, is what we found out in 9.3. So how do we know that they're similar to each other? Well, for example, like if I know this is a right angle right there on the big triangle in comparison with the little triangle, that this little triangle, like there's an altitude right here, so that's got to be a right angle right there in the corner too. So thus I have two right angles. On the big triangle that's a right angle, on the little triangle that's a right angle. But one angle on two triangles is not sufficient enough to be able to say that the two triangles are similar. I would need at least another angle congruent. Well, remember I took this one and I replicated it from this big triangle. So both of them have angle A, the exact same angle. Okay, those two angles are the exact same, so thus I have each of them have a right angle, and both of them have like angle A, the exact same angle A. So thus I have two angles that make them congruent to each other. Thus these two triangles are similar to each other because of angle-angle similarity. Now you might be looking at these and saying, well, how the heck are these two similar to each other? They don't look similar to each other at all. Well, if I just manipulate this a little bit, like I can actually take this one and flip it over, and you can see that, oh yeah, actually these two triangles do look similar to each other. One looks just like a bigger version of the other one. Okay, so they are in fact similar. If I want to compare these two triangles, they're going to be similar to each other as well. Again, the big triangle has got that right angle, and then this triangle on the right, that was an altitude, so that angle in the corner there's got to be a right angle. Okay, that's what this one is. It's a replication of that one. So that angle right there is also going to be a right angle. So thus, each of them have a right angle, and they also have angle B in common, right? Angle B on the medium triangle and angle B on the big triangle are the exact same angles. So thus I have angle-angle similarity. This big triangle and this medium-sized triangle are thus going to be similar. Again, you might be looking at like, well, how are those two similar? Well, if I take this one and I flip it around, okay, you can kind of see that, yeah, those two are in fact similar. They're just different sizes. So if these two are similar, and we know that these two are similar, then the medium one and the small one will also have to be similar to each other. If you're like, I just don't see how all these are similar to one another, well, I can take this one and flip it over, this one and flip it over. You can see, yeah, like all of them even look similar to one another. But we've proven it because they each have two angles similar to each other. So we know that if we have two triangles that are similar to one another, then the ratio of the sides are going to end up being the exact same. So the ratio of the sides, well, if I compare like this big triangle to this little triangle, remember how they both had AC in common here? Okay, that side they have the exact same of. Since they have that exact same side in common, I'm going to make that my geometric mean. So this is segment AC. I'm going to set up a proportion here. That side that those two have in common, I'm going to make those my geometric mean. And then if I do a comparison of, okay, so I'm going from big triangle to the small triangle. From the big triangle to the small triangle. Okay, so on the small, so I'm going to go big to small, big to small. So on the small triangle, side AC, let's look at it. that would be on the small triangle. Side AC is the hypotenuse side of this triangle. There's the right angle, that's the hypotenuse side. So if I look, well, which side is the hypotenuse side on the big triangle that matches up with it? There's the right angle. The hypotenuse of that triangle then would be side segment AB. So both of these two are hypotenuse. This is the hypotenuse on the big triangle to the hypotenuse on the small triangle. Or if you're looking like, okay, so this hypotenuse right here on the small triangle, side AC, right? If I flip that around, oh yeah, that one right there matches up with AB over here. So thus, those two would have the same ratio as, I can set up another two sides that are similar to one another. So again, I'm going from, just the way I'm writing it is from big to small. So on the big triangle, segment AC on the big triangle, okay? My segment AC on the big triangle, well, if I look, this is the hypotenuse, so these two have to be legs. This is the smaller leg. So if that's a smaller leg, well, which one does that match up with on this one? Okay, so on this triangle, this is the hypotenuse side, this is the longer leg, so this must be the smaller leg. So that's got to match up with this segment AD on the smaller triangle. So thus I have my proportion set up. Okay, so segment AC on this one actually matched up with this segment right here on the little one, which is segment AD. Okay, and I just went from big to small. So I can set up that ratio. If I look at the medium-sized triangle with the big triangle, let's see which ones they have in common. There's all kinds of like ratios and stuff I can set up, proportions I can set up here, but what's the interesting ones are the ones where they have two sides in common. So if I look between the big triangle and this medium-sized triangle, they both have sides CB that are the exact same with one another. So I'm going to use segment CB as my geometric mean. So CB and equals something else with CB, and maybe this time I will go from the big triangle to the medium triangle. So from the big triangle to the medium triangle, so big to medium. Alright, so on the medium side, CB on the medium triangle, that's the hypotenuse side of this triangle. So if I look at my big triangle, which side does that hypotenuse side match up with? This is the hypotenuse, there's the right angle right there, so that's got to be the hypotenuse side of the big triangle. So side AB on the big triangle would match up with side CB on the little triangle, right? This side matches up with this side right there. They're both the hypotenuses, I don't know. Okay, now going back to the big triangle, let's look at side CB on the big triangle. Side CB is the longer leg, so that matches up with, okay, there's the hypotenuse, there's a short leg, there's the long leg on the medium triangle is side DB or BD. So there's a proportion, another proportion that I can set up where CB, the two sides that they have in common, is the geometric mean. And I did the same thing with the little triangle and the big triangle, right? That was up here. They both had side AC in common, so I made AC the geometric mean there. Now I'm going to look at these two. I haven't done those two yet. Well, what side do those two have in common? What? Like, well, yeah, they actually have the original altitude in common, right? They have this one right here in common, but that's the only one that they have in common with each other is segment CD. So I'm going to make that one my geometric mean. And this one, I'm going to go from let's go from the small triangle to the medium triangle. And these should align with your notes that you've already taken. Okay, so let's see here. From the small to the medium, small to the medium. So small to the medium triangle would have segment CD. Okay, segment CD on the medium triangle. That's the shorter leg. And if I look at my little triangle, the shorter leg would be segment AD. Okay, small to medium, small to medium. Okay, on my small triangle, segment CD, that's the longer leg on my little triangle, and that's got to match up with the longer leg on my big triangle. Is not CD, it's actually DB. This is the short one, this would be the long one. Or you can look and see that, okay, well, if I flip this to make it look like that one, CD on the little triangle would actually match up with, how would I'd have to do it this way, right? CD on that little triangle would match up with DB on the big triangle, okay? Or not big triangle, I guess that's the medium triangle. Alright, so we've got our proportions, and if you notice, like, you can cross multiply these are the proportions, but there's also some equivalent equations. Like this turns into, if I cross multiply, I'm going to have AC squared equals AB times AD. And this one will turn into that geometric mean, that one that they had in common, that side CB that those two had in common. It will turn into that side they have in common squared equals AB times DB. And then for this one, if I cross multiply those, then that geometric mean CD squared, that's the side that the medium one and the small one had in common, would have to equal AD times DB. Now, you can use either proportions or you can use these equations. I don't really care, but it's very, very annoying to be writing out all the time, like all these different letters constantly. So we like to use what we, rather than using those letters, instead what makes it easy is, because it gets confusing, like when I say CB and there's like there's two triangles that have segment CB. So I'm going to redraw that altitude and hypotenuse that we've got going on here. This was angle A, this was angle C, this was angle B, and then we called this point right here D. Now, so that way when I say CB, you can easily, rather than having to write CB all the time, instead what makes it convenient is, well, CB is opposite angle A, so what makes it more convenient is to call that lowercase a, because it's opposite the angle A. Opposite angle B is this segment AC, which I'm going to call a lowercase b. Opposite angle C here at the top, well, on the big triangle, that would be this whole segment right here, so I'm going to call that lowercase c. And then this is like the height of that triangle, so I call that H, and then these two right here, well, they don't have anything, and so we just call those like X and Y. So, looking at that triangle, let's see if we can't come up with these proportions again using those letters instead. So from the little triangle to the big triangle in here, they both have in common that segment B, little triangle to the large triangle. So I can set this proportion up as, well, they both have B in common, and then B on the little triangle. Okay, on the little triangle, B is the hypotenuse, right? It's the hypotenuse of that little triangle. So it'd have to match up with C on the large triangle would be the hypotenuse. And then B, if I'm looking at the big triangle now, so I'm coming up with the second fraction over here, B on the big triangle would be the short leg, and that would have to match up with the short leg on the little triangle. And I know my picture's not that great, but the short leg on the little triangle would be this little piece right here at the bottom. So that would be X. Or that equivalent would be B squared equals X times C. These are the proportions, these are the equations that I've had you write out on the 9.3 notes. Okay, if you don't have those, then write them down. Then if I compare the medium triangle to the large triangle, the one side that they have in common is this side A. So that's going to be my geometric mean. And segment A, okay, so segment A on the medium triangle is the hypotenuse side, and on the large triangle that matches up with segment C is the hypotenuse on the large triangle. And then segment A on the large triangle, because I'm going from large to medium, okay, segment A on the large triangle is the longer leg, and so if I go to the medium triangle, the longer leg would be segment Y, or its equivalent would be A squared equals Y times C. Okay, little easier. It's equivalent to all these other ones that we're writing over here. It just looks a little bit cleaner this way. And then the last one, I haven't done the small triangle with the medium triangle. The small triangle and medium triangle have H in common. So I'm going to make that the geometric mean. H on the little triangle, okay, H on the little triangle is the longer leg, and the longer leg on the medium triangle is segment Y. And segment H on the medium triangle is the smaller leg on the medium triangle, so the smaller leg on the small triangle is segment AD, this bottom one, X, so that equals